put them together, so if you could help me vet the videos, that would be helpful. Super helpful. All right, so today what we're doing is we're doing the quadratic, we're going to finish up quadratic factoring review, and then we're going to get into equations and applications. We might start on the review for exam, I'm not sure, but today you have due the quadratic functions. So what I might do is, I think it's just one problem that you should not be able to solve, which we're going to do today. So I can bump that to tomorrow, if that helps. So it's due tomorrow instead of today. So then you'll have an extra day to work on that one. And then Monday is that factoring trinomials, which is the stuff we've been working on the last couple of classes. And then Wednesday we'll have solving quadratic equations, which we're going to get into today as well. I want to have the exam next Wednesday on units 4 and 5. So really, if you can try to get this one done, or at least started practicing that before Wednesday, before class, that would be my suggestion, so that you don't come into the exam, that you do this before the exam. That would be my suggestion. Right. The other thing I could do is, we could move the exam back to Friday, but then that means that Wednesday we're going to be learning new material, which I think might be confusing.
There's no school on Friday, I think. It's Veterans.
Oh, right, it's Veterans Day, perfect. So yeah, so I think that works out really well.
Well, that's
Oh, we have Monday.
Friday.
Friday,
Oh,
Friday off for Veterans Day.
next Friday.
So the other thing that we could do is, right, and the other thing we could do is we could bump it to Monday, which would give you a long time to study it, but then again, Wednesday we'd have to cover new material, which might be a little bit confusing.
Yeah.
So I'm open to either one of those options.
I'd rather just have it Wednesday
Yeah, I'd
personally,
rather-
because I don't want to get confused by
Yeah.
new material.
I don't wanna
Old
forget.
stuff there.
Okay, sounds good. So everybody go ahead and bust out your factoring, quadratic factoring review. Sorry. Works.
And you know, one of these papers that I guess we never completed.
Yeah. Yeah. And on the video, she asked, like, if the class is good, and in my mind, I'm like, no.
When you're done with that part, come up with a second. Okay. So we'll go ahead and slide down. We are currently on page, so we did all those ones. We did the we did the trinomials. This is the last thing we did. Was these guys here, I believe? Oh no, we did the difference of two squares. Yeah, these are great. Right? These are super fun.
We're on use factor.
We started with 5, we didn't finish all the
Okay.
problems.
Got it. Right. So we just
4.
so far what we've gotten to is using that really cool zero property product property, which means that if I have a quadratic and I make it into something times something equals 0, it can't equal 5 or 1 or some number. Everybody on board? Because a times b times c equals 0, I know one of them must be 0. But if a times b times c equals 3, they could be anything. Does everyone understand what I'm saying? So it has to be, the key is, you have to make it equal to 0. If it equals 4, you have to subtract 4 from both sides to make it 0 on one of the sides. Does that make sense? If it was, or if it's, equals 2, you have to add 2. You have to subtract 2 from both sides, so that and that's what I call setting it equal to 0. That's what I call setting it equal to 0. So you have to. There's a number over here. You have to subtract it from both sides so that this side is 0. So whenever we say set it equal to 0, that's what we mean. In other words, add or subtract something from both sides to get this to equal 0. Good?
Mhm.
Okay. So here, what we said before was, if you get into this situation here, then you can just say that, oh, x minus 3 equals 0, and 2x plus 1 has to equal 0. So then you can solve them. Here I'm going to add 3 to both sides. Right, plus 3, and I'll get x equals 3. That's one solution. Over here, I have to do a couple steps. I'll draw my little line. First, I have to subtract 1 from both sides. And I get 2x equals negative 1. And then I need to divide both sides by 2. So then I end up with x equals negative 1/2. So these are my two solutions then. This one and that one. And you can just circle, you can just box them like that, or off to the side you can say x equals 3, comma, negative 1/2. That means it equals those two numbers. Either way is fine, either this way or that way. All right, so you folks need to do, I feel like we did the first one. Did we do the first one?
We
did.
Yeah.
Right, so we did the first one together, where we said, okay, here's our x, a times c, which is 6. You have to multiply to 6, and then add to ac plus b, which is negative 5. So which is negative 5. So two numbers that multiply to 6 and add to negative 5. They multiply to 6, they have to be the same sign. Anytime that when you multiply to a positive number, you know that they either have to both be negative or both be positive. Because the only way that this is positive is if a positive times a positive or a negative times a negative. So it has to be the same. So two numbers that multiply to 6 that are the same sign, which means they have to, so think like this. If this is positive, they have to add to this number. If this is negative, then it's a difference. The difference between them has to be this number. Is that kind of an easy way of thinking of it? So this is positive, so two numbers I have to add to negative 5. Negative 2 and negative 3. Right, because 6 and 1 won't do it, they add to 7. So this is going to be negative 2 and negative 3. And because my a is 1, there's kind of no number in front of the x squared, then I can go straight to this. That's right. And then, like I said, we split these out into two spots. X minus 2 equals 0, x minus 3 equals 0. All right, so I'm going to let you folks do this one. And do the rest of the other three on your own, in your groups on your own. So go ahead and do that. Listen up, Eric's going to explain what he did for the second one. Over here.
Yeah, so I just, first I did the x, I don't know what you call that thing, but, you know, the x to find the factors.
Right, the AC plus B method.
Yeah, the AC plus B method, so I just marked them first so I get everything clear.
So
Which one's A, which one's B, which one's C.
Mm-hmm.
And then I did A, because obviously there's a hidden 1 there, so I did 1 times 21, 1 is negative 21, so I put that in the top. And then I put, on the bottom, it's plus B, so I just put the negative 4 on the bottom.
Great.
And then I said to myself, well, what two numbers multiply to 21 but add up to 4? So I said 7 and 3 is the only thing I can use, right?
Right.
So I put negative 7 plus positive 3 equals the negative 4.
Perfect. So then.
Then I come down here, and then I do the boxes, so I just put x, x, and then I put the two numbers there, so negative 7 and equals 0, and then plus 3. So I took those from the two sides of the
From those
axis.
two sides, yeah, from the 3 and the negative 7.
And then, so once I set those to 0, and then I just am trying to remove the 7 from inside, so I solve for x. So then I just added 7 to both sides of the equal sign.
Mm-hmm.
And so I got x equals 7 and x equals negative 3.
So yeah, so then you subtracted 3 from both sides over here.
Yeah,
X equals negative 3.
so those are the two x coordinates, I guess.
Thank you. Talia is going to explain just how she did the last one. Oh, this one down here. Go ahead.
I needed it to equal to 0, so I moved 9 to the other side. And then a times c, which is 9. And then the b is 6.
Mhm.
And then so what times what would equal 9 and adds to 6 would be 3 and 3. Everything's all positive. So x plus 3 equals 0, minus the 3, x equals negative 3, same with the other
Same
side.
with the other side. Perfect. Perfect. So x equals negative 3. Thank you. And then Fox is going to explain what she did for the last one.
Okay, so I did, the first I moved the 3x squared to the other side, and since you want, and that would become negative 3x squared plus 11x plus 4, but then the teacher said that the x squared is best when positive, so
Yep.
I switched all of the
Signs.
the signs.
She basically multiplied everything by negative 1.
Yeah.
Totally works. Yeah.
And then, in order to deal with the 3 at the beginning, we did a box graph. And we put the 3x squared in the top left
Oh,
corner.
well, you did this one first, though, didn't you?
Oh yeah. Yeah. So there was 11 and the 12 because 3 times negative 4 is negative 12, and the negative 11 is in the changed graph,
Mm-hmm.
and negative 12 times 1 is negative 12, and negative 12 plus 1 is negative 11. And so we plugged those two numbers into the square graph.
Okay, so those two went into the, so in the first spot you put the first number in the first spot, last number in the last spot, and then these two spots you put these two numbers in there.
Right.
1x and negative 12x. These are your x, these ones are the same thing as the negative 11x term. Okay, great.
So then I determined what negative 12x and negative 3x squared had in common, which is 3x.
Mm-hmm.
Then I went to figure out what 1x and negative 4 have in common, which is a positive 1.
Mm-hmm.
And I figured out what 3x squared and 1x have in common, which is a single x. And then what negative 12x and negative 4 had in common, which is negative 4. So then on the side I put 3x plus 1 and x plus 4. And
X minus 4. X plus
x
negative
minus 4. And for the x minus 4, I just did it in my head since it's rather simple.
You added 4 to both sides, uh-huh.
We added 4, but it became x equals positive 4. And then for the other one, I first moved the positive to the other side, which made it a negative 1.
Mm-hmm.
Divided both sides by 3, and then x equals negative 1/3.
Did someone do it with the, Kelly, we'll use yours because you did it with the other method, right?
Yep.
Okay, so that's the box method. And then Kelly's going to show how she did the other method, the factor by grouping method. Go ahead.
Oh, I have to explain it?
Yes.
Alright, so first I subtracted 11x and 4 from the one side to get them all to the other side. And then I dropped everything down. And then I was left with 3x and negative 4, and I found the factor.
Ah, so so you found this part, you dropped those parts down
Yeah.
and left a big gap in between.
Yeah.
Then you figured out the factors.
Yeah, and then I figured out the factors, it was either negative 12 and 1 or negative 1 and 12.
Okay.
And I figured out it was gonna be negative 12 and 1, and then from there,
Group these two.
I grouped those two, and then I grouped the other two. And I pulled out x from 3x plus 1, and then pulled out negative 4 from negative 12 minus 4, and I was left with negative 4, or x, and then 3x plus 1, and then negative 4, and 3x plus 1. And so I grouped the x and the negative 4 together,
Mm-hmm.
and then 3x and plus 1 stayed together, and then,
So then she said that x plus minus 4 equals 0, so that became x. If you add 4 to both sides, you get this. And then she kind of did similar that Foxy did, only I think she, found out what so many Fox numbers. Great.
So she factored on 2 steps, pulled out, yeah.
She did it by grouping,
Yeah.
yeah, which is another way.
Yeah.
Good. So, thanks for that. And here you go. So what we're gonna work on next is going to be our last handout. The last one is, let me get this, where is it? This one. I'll pick these back. Right?
This plus minus, whatever you call this, square root thing, I was like, what the heck do you do
Yeah.
with that?
So this is gonna help us a little bit. We're getting some more practice of this one, so here's the first example. We'll do this one together. So here, this is a nice one because my a is 1, there's no number in front of my x squared, so it's gonna be one of those simpler ones. So I'm gonna say, okay, a times c plus b, my ac is negative 45, that's the times part, and then my b is negative 12, so two numbers that multiply to negative 45 and add to negative 12. Okay, so 45 is like
96.
5 and 9, and 15 and 3, and 45 and 1, right? So since my negative, when I multiply them, I have a negative. That means one has to be positive, one has to be negative, right? The only way that this is negative is if one's positive, one's negative. So I need to find the difference of them, because one's going to be positive, one's going to be negative. Where the difference is 12. So which of these has a difference of 12?
15.
Well, yeah, 5 and 4 is only, 5 and 9 is only a difference of 4. 45 and 1 is a difference of 44. 15 and 3, there's 12 between them. Does that make sense for folks? So it's going to be 15 and 3. So 15 and 3 go in there. And which one has to be negative? Well, since they add to negative 12, that means the bigger one has to be negative. Whatever the sign is of the B is the sign of the larger one, because that's going to dominate. That's a good, I like the word dominate, that's perfect. That's totally, that's accurate. All right, so then I can go straight to this. X plus 3, x minus 15 equals 0. All right, don't forget the equals 0, which means that either x plus 3 equals 0, or x minus 15 equals 0, which means that here I can subtract 3 from both sides and get x equals negative 3. Here I'd add 15 to both sides, so I get x equals 15. So those are my two answers. So I'm gonna make you folks do the next two. I should have had you do all of them actually. My bad. So do the next two, and then we'll come back.